So today we're not just talking about AI, we're talking about how to build truly intelligent AI. And the secret? Well, it isn't just in the code, it's in the blueprint, the agent's architecture. Think of this as your ultimate toolkit for building the next generation of AI. So let's dive right in. Okay, so here's the big question, right? How do you actually get from a pretty basic chatbot to an AI that can genuinely think, plan, and, act in the world? That is the fundamental challenge we're all facing. And the answer, it turns out, lies in its internal design, its architecture. At the end of the day, an agent's architecture is really just its blueprint. It's the master plan that decides how it sees the world, how it reasons, how it plans, and even how it remembers things. It's the whole internal structure that makes it tick. All right, here's the game plan for today. We'll kick things off with what agent architecture even is. Then, we'll get into the nitty-gritty, how an agent thinks, how you actually build one, and how it remembers things. After that, we're going to talk about building and controlling entire teams of these agents, and we'll wrap it all up with the architect's final blueprint. First up, what is agent architecture? Let's lay the foundation. Understanding this stuff is really all about navigating trade-offs. You're constantly balancing things like capability versus complexity, or autonomy versus control. And trust me, every little decision you make here is going to have a ripple effect on everything else. Okay, on to our first major decision point. How does an agent think? This is a huge one because it basically sets the stage for the agent's entire personality, how it solves problems and deals with the world around it. So you've basically got two main flavors here. On one side, you have your reactive agents. The best way to think about these is like a reflex. Input comes in and bam, an action comes out based on a simple rule. No thinking, just doing. But then on the other side, you've got deliberative agents. These guys are the chess masters. They actually model the world, they think ahead, and they plan out their next moves. So when do you actually want one of these reactive agents? Well, anytime speed is absolutely critical. We're talking real-time systems, super simple control tasks, basically any situation where you need a lightning-fast, predictable response. That's where they shine. And what about the deliberative ones? Well, these are for the heavy lifting. Think about building an autonomous workflow or handling a really complex, multi-step task, like, say, planning an entire vacation from start to finish. Anytime an agent needs to be goal-driven and figure things out when there's uncertainty, this is what you want. You're basically trading a little bit of speed for much, much smarter decisions. Okay, so we've decided how our agent thinks. Next up, how is it actually built? This is all about the structure, the nuts and bolts. Are you going to put everything into one big box or build it out of a bunch of smaller, specialized pieces? Right, so you've got two main approaches here. First is the monolithic design. Everything is packed into one tightly knit system. Honestly, think of it like an iPhone or a sealed laptop. It's simple, it's all in one piece, but boy, is it a pain to fix or upgrade. The alternative is a modular approach. This is way more like a custom-built gaming PC, right? You've got all these separate, independent parts that you can easily swap out, upgrade, and scale on their own. And yeah, that monolithic approach, it comes with some serious red flags, especially for complex systems. They're a nightmare to maintain, super hard to debug, and you get almost no flexibility. Worst of all, since everything's so tightly connected, if one little piece breaks, the whole thing can just crash. This is exactly why, for pretty much any serious production-ready system, you're gonna want to go modular. It lets you have a clear separation of concerns, which is just a fancy way of saying each part does its own job. This makes the whole agent way easier to debug, to maintain, and to add new features to later on. It's a design that's really built to last and to grow. All right, our agent can think, and we've given it a structure, but now for a really crucial piece, memory. How does an agent remember? This choice is what separates a one-off interaction from a real, ongoing conversation. It's all about context. And that brings us to our next big choice. Stateless versus stateful. A stateless agent is basically like having no short-term memory at all. Every single time you talk to it, it's a completely fresh start. A stateful agent, on the other hand, remembers. It holds on to context from past interactions, so the conversation can actually build on itself. So you might be thinking, why would you ever want an agent that doesn't remember anything? Well, it's perfect for those simple one-shot tasks. Think of a really basic Q&A bot. The beauty of stateless agents is that they're super easy to manage, and they can handle a ton of requests at the same time without breaking a sweat. But let's be honest, the real power, the magic, it comes from stateful agents. This is what makes things like personal assistants and truly autonomous agents possible, the ones that actually learn from you over time. But, and this is a big but, there's a trap. With great memory comes great responsibility. You have to actively manage all that stored information to make sure it stays accurate and useful. Okay, so far we've been focused on designing one single awesome agent. But what happens when a task is just too massive for one agent to handle? Well, that's when you stop trying to build a bigger agent and you start building a smarter team. Let's talk about scaling up. Yeah, for really tough problems, a single agent just becomes a bottleneck. The solution is to create a multi-agent system. It's all about division of labor. You build a whole team of specialized agents that work together. Each one is an expert at its one little piece of the puzzle, and together, they can do way more than one single general-purpose agent ever could. And here's a super common and really effective way to set up that team. It's like a little playbook. First, you've got a planner agent. Think of this one as the project manager. It takes the big goal and breaks it down into smaller steps. Then you have your executor agents. These are the specialists, the workers on the ground who actually do the tasks. And finally, you have a critic or validator agent. This is your quality control, making sure the final work is actually good and meets the original goal. So who's in charge of this whole operation? Well, you have two choices. You can go with centralized control, where one main agent is the boss, telling everyone else what to do. This is great for situations where you need tight control and predictable results. Or you can have decentralized control. Here, the agents kind of figure it out amongst themselves. They self-coordinate, which can be way more flexible and scalable, especially for fully autonomous systems. Phew, okay. We have covered a lot of ground. Now it's time to bring it all together into the architect's final blueprint. And here's the most important thing I want you to take away. There is no single best architecture. It just doesn't exist. The real skill, the art, is in making the right trade-offs for whatever it is you're trying to build. And this matrix right here, this is really the core takeaway of our whole chat. Every single choice has a gain and a cost. You want the smarter decisions that come from a deliberative agent? Okay, but you're going to pay for it with more waiting time. You want that awesome scalability of a modular design? Cool, but get ready for more complexity up front. Let me give you an example. If you were building an AI to help diagnose medical conditions, you would absolutely trade a few extra seconds of latency for a more accurate deliberative decision, right? That's the balancing act. That's the job of the AI architect. So, as we look to the future, what are the big principles to keep in mind? Well, first, design your systems so they can actually scale on modern GPUs. Second, really embrace those modular, microservice designs we talked about. And finally, always build in ways for you to see what your agents are doing and to control them. It's all about finding that perfect sweet spot between raw performance and true autonomy. So there you have it. We've just unpacked the entire architect's toolkit, from how an agent thinks all the way up to how you manage a whole team of them. You now have the blueprints. The future of AI really is in your hands. So the only question left is, what are you going to build?